in this problem, there is a ball, a 20 kilogram ball with the initial with an initial velocity of 2 meters per second, and it is at a height of 20 meters. And then on the bottom is a trampoline with a height of 1 meter that and the trampoline has a spring constant of 100 newtons per meter. So this ball is gonna fall onto this trampoline, and the question is, how far will the spring within the trampoline compress? So the first step, since we know that the total energy initial will equal the total energy final. So the total energy initial is going to be the gravitational potential energy initial, which is the potential energy of this ball at the top of this height, plus the kinetic energy initial of this ball, also at this height, will equal the gravitational potential energy final of the ball once it's down at the trampoline, plus the kinetic energy final of the ball once it hits, or before it hits trampoline. So using these equations here, we can, so like GPE is mgh, so mgh plus 1/2 mv squared equals mgh plus 1/2 mv squared. And if you notice that mass is in every part of this equation and is also on either side of the equation, we can cross all the mass out. So gravity is always 10 times the height, which is 20 meters, plus 1/2 initial velocity is 2 meters. 2 meters squared equals 10 times the height, which is 1, plus 1/2, and then we're trying to find what this final velocity is here. So this will leave us with 200 plus 2 equals 10 plus 1/2 v squared. So by the end, this will be v equals about 9.6 meters per second. So now we want to take the elastic potential energy of the spring and the trampoline and set that equal to the kinetic energy of the ball when it will hit the trampoline. So this the elastic potential energy equation is 1/2 kx squared. So K being the spring constant, which we know is 100 newtons per meter, and X is how much the spring will compress or stretch. And this is what we were trying to find. Set that equal to kinetic energy, which is 1/2 mv squared. And in this case, we will need the mass since there's not mass on this side of the equation. So then K is 100, and 1/2, the mass of the ball is 20 kilograms, 20, and then the velocity, which we just found, is 19.6. And then we need to square that. And so in the end, X is going to equal about 8.76 meters once you isolate it here. And this is the answer. So this is how far the spring will compress once this ball hits the trampoline.